So if you head down to the resources section, you'll find the file called overflow underflow. So you can open that up if you like in order to follow this. So if you're in there, we'll be at the top level here, which is the test section. So let's go into the actual multiplier here first of all. Now there's no changes throughout the circuit other than in this part of the circuit here. So this is the first adder that we come across, and you can see that I've got an extra input here, which is just the sign of the output, and we've got 4 outputs here as well. So let's head in, we'll see the difference here. Now previously in this adder we just had the 2 inputs, the adder and the output, but now you see we've got all this extra circuitry here. So let's talk our way through this. We're going to start off with this little section and this little section. Now you can see here that what this little bit does, it tests for negative inputs. By negative I mean the exponent is negative. So we're going to test and find out whether the exponent here is a negative value, and we're going to test and see whether the exponent here is the negative value. And in this bit down here, we're testing to find out whether the exponent values are positive values. So both of them would have to be positive in order for this to go high. So let's have a look and we'll see how we get these from the spreadsheet. So if you head into the spreadsheet here, now again it's just the same as before. I've got the range, I've got the sign decimal, I've got the type. Now if we were to try and figure out whether both of the inputs are positive, I'll just get rid of my image here so you can see the whole thing. So in order to find out if they're positive, then you can see that we'll get positive values all the way down to here. Okay, so that positive value goes all the way down to the actual value there of 255. So what we need to do is test to find out whether the value is less than 100, so that's 100 in hex. So as long as it's less than that here, then we know we're going to have a positive value. Now in order to test and find out whether we've got a negative value as well, the negative values are going to start at this point here, which is at 256. So we just need to test and find out whether we've got values that are going to be greater than the 255, which is the FF. So we can just use these in order to make the test, and that's what we've done here in Logisim. You see that we've tested here for the positives to see if the value is less than this 100 in hex, and we've tested for the negatives to find out whether the values are greater than the value 0FF in order to get the negative values. So I've opened up the spreadsheet here, and again we've just got the columns we've seen previously. Now let's look at the instance where we are going to add together 2 positive numbers. So we know the positive numbers are going to range all the way from the value 0 all the way up to the value of 255. Now if we had 2 of these numbers together, then the maximum we could possibly get out of this would be the 255 plus a 255, which is maybe 510. So that would mean that the adder would still be within its range. So the adder's range would be up to 511. So we wouldn't have any overflow in the adder. Now when I talk about overflow in the adder, I mean we wouldn't have any carry out in the adder if we're going to add together these 2 positive numbers. So we don't need to bother or worry about that. But what we would have to do is we'd have to note that if we were to add the 2 numbers together, we do have the possibility of arriving at any point in this list. So we could end up coming out to say where it says there's an underflow. We could come out to subnormal. It could come out to the normal. So it could land anywhere when we added these 2 positive numbers together. But what we can do is we can say, but we're only interested in it whenever we are going to overflow to plus infinity. So what we can do is we can say, well, we'll do another test. Once we know we've got two positive numbers, we can do another test and we can say, well, if the numbers add up to any more than 128, then we'll just call that an overflow to plus infinity. So in this case here, we would have an overflow to plus infinity here. But we could add those two numbers up and we could end up getting a number, say 258. And all we need to do is then we'll just call that an overflow to plus infinity as well. So every number that's going to be greater than the 128, we just call it an overflow to plus infinity. But we also have to do it only for the two numbers being positive. So that's our first test, and that's our test for overflow to plus infinity. So let's have a look and we'll think about how we're going to do our test for our, in fact we'll just go into the Logisim and we'll show that working first of all. Find the correct Logisim, that's it here. So this is us in Logisim, so I'll fix the screen here for us to make it a little bit better. Okay, so that's us back in Logisim. So we've done that test there to find out whether both are positive. So we've got a positive input, and then we're going to test to find out whether we've got a value that's any greater than that number 080. So this is the top of our normal number range. And if we do have this and we've got two positive numbers coming in, then we're going to get an output here. Okay, so that'll do for this little bit. Now we'll talk through if the values were two negative numbers, and the two negative numbers, we've got an extra added complication, because if we've got two negative numbers, we will potentially have this carry out going high and generating a number here which is actually just gobbledygook of actually no use to us. So let's go in and have a wee look at this in the spreadsheet. So let's say we've got two negative numbers. So the negative numbers start up at 256 and they go all the way down to our value here of 511. So that means that if we were to add the two negative numbers together, then we could potentially get a number which will overflow outside the maximum range of our adder. So our adder is up to 511, and this could overflow up to instead of the 9th bit, it would overflow up into a 10th bit, which we don't have. We would just have an overflow flag would come up in the adder. So how are we going to deal with that? So let's say our inputs are negative numbers. Okay, so in order to get negative numbers, we're going to have numbers that are greater than 256, greater than 255. So these are going to be our negative numbers. So when we add our negative numbers together, you can see here that if I start at 256, then we could add these numbers together and we can very easily get an overflow in our adder. So we'd, for example, we would have, if we had 300 plus 300 is going to give us 600, but 600 is out with the maximum value you can get in the adder. The adder will only go up to the 511 because it's a 9-bit adder. So in effect what would happen here is we would get a carry bit, and it would be a flag saying, look, we've carried a value out and then we've got this other value here, okay, which is the output. Now the output value will be correct. So for example, if you decide to add minus 2 plus minus 2, you'll get minus 4. If you added together minus 100 and minus 100, we would get the correct answer. We would get minus 200. But if we try to add together, say minus 150 and minus 150, well, that would give us an answer of minus 300. But it doesn't go to minus 300. We only go to minus 256. That's as much as we'll get to. So what actual answer would it give us in that case? Well, the answer it would have given us in that case would be an answer which would be sitting in here somewhere, and it would actually give us a positive answer. It would say minus 150 plus minus 150 would be something like, say, 20. I'm not going to work it out in my head, but it would be something like 20, so it would be a positive number, so it would just give us nonsense. So we have to take account of that, but we can take account of it quite simply, because what we can say is, if the number that we get out is less than the value of 363, so this is the smallest subnormal number, and this is us just getting into the underflow to 0. So we say if it's less than this number 16b in hex, then we just say, well, all numbers that are less than this are going to be an underflow to 0. So all of these will be underflow to 0. All of these here as well will be underflow to 0 as well, all the way up through, and we just call these all underflow to 0. But remember, they're only underflow to 0 if we make the assumption that we're going to have, or do the test and make sure we've actually got two negative inputs. Now, if we had a positive and a negative input, we wouldn't have a problem. We wouldn't have it underflowing below 0, and we wouldn't have it overflowing to infinity, so we don't need to bother about that case. So let's have a little look at that, and we'll see it in Logisim. So I suggest one thing that you can do if you're not quite following this is you can get an actual adder and put an adder in Logisim, put a couple of inputs in, put an output out, and then just vary the numbers and check and see the values you're going to get. And you are going to get some values that if you add two negative numbers together, it will give you a positive output. And that's just because it's overflowed beyond the maximum negative value that the adder can actually do. Okay, so that's us got this here. We've got the test here for the negative outputs, and we're testing to find out whether the range is less than this value 16b. And if it is, we're going to get an output here. So this is going to tell us whether, this point here is going to tell us whether we've got an underflow to 0, and this point is going to tell us whether we've got an overflow to infinity. But it doesn't tell us whether it's going to be plus minus 0 and plus minus infinity, but we can generate that quite easily. All we do is we take the output, the signed output for the multiplication, and whenever we got the signed output, we can just put this through a couple of demultiplexers. So if I click on that, you'll see it's a demultiplexer. So it takes that one input and it gives us two outputs. And the two outputs are decided on by this value here. So if I just run through this here, you'll see that if the output is low, then it's a positive number. So therefore you get a 1 out here. If the output is high, it's a negative number. So you get a output here. And the same would go for this one as well. So there's quite a lot involved in that. And if you have any difficulties with it or you're unsure, you can always get in contact. But definitely go ahead and build a little adder circuit yourself and check, and you'll see how all of the numbers get added. So finally, let's go back to the top level, and I'll make this a little bit neater for us so we can see it better. So if we go back to the top level, you can see that what I've done is I've taken those plus infinity, and we've got the minus infinity, we've got plus 0, and we've got minus 0, and I've taken the 4 pins out and I've taken them to the top level. And at the top level we've got the plus infinity, minus infinity, plus 0, minus 0, and we've got the little connections here as well, so the tunnels to these points, and we've got some lights here as well that will just light up. So if the plus 0 goes high, it just goes out to red, and if it's low, it goes green. And it just gives us a way of having a visual display of what's happening with these, and in effect will become their flags. So let's have a look at an actual example. If you run up the spreadsheet, click on Multiplier, and we can put in a couple of numbers. So let's say we have 1e to the 20, and we multiply that with 1e to the 20. So that's going to give us 1e to the 40, so it's going to overflow to plus infinity. So what we can do is we can take a note of these numbers, and we'll put these numbers into the Logisim, and we'll see this overflow to plus infinity. So we can put our values in here. We're going to have our 60 AD 78 EC, and the same in the other one, 60 AD 78 EC. And you can see here the flag has come up overflow to plus infinity, and if you head down into the section here, you'll see that we've got the two positive inputs and the overflow, it's in the overflow range here, so that's gone high here as well, and it's also a 0 at the sign bit, so it's going to give us a 1 at plus infinity. So that's all there is for this video. You'll notice one thing here is that the output, although we've got an overflow to plus infinity, the output's still giving us a number here. Because we don't know what plus infinity is, we don't have any special values like plus infinity, and we're going to have to look at that next. So thank you for listening, I'll get you in the next video. Goodbye.